story in the house of cards. And I said, okay, well, on the top story, or if I call that still the first story, I have 2 cards. And then on the second story, I noticed that I have 2 lots of those same 2 cards that I started with. So I need 2 cards to make one little triangle in the diagram. And then in the second story, I have 2 of those triangles. So that's where the red triangle is coming from in my numbers on the side there. And then I needed to add 1 to get the horizontal one so the top story could rest on it. Then I just extended that for the third level down, and I notice I need 3 of those triangles. So to make 1 triangle, I have 2 cards, and I have 3 lots of them to make the 3 triangles, and I need 2 of the horizontal. And then I just extended that, and then you can read for yourself for the 4th story. And then tried to predict then what would it look like on the nth level of this house of cards. So on this level, I noticed a pattern that it's always the story number, that is the red number, times 2 lots of 1, or just the 2 times 1 cards. And then it's what I add on is always 1 less than the story number. Okay, there it was story number 4, but I added 3. There it was story number 3, but I added 2, and so on. So I said, okay, on the bottom row of this house of cards, I would have n lots of 2 plus n minus 1. Now to get the total though, that's just looking at each level on the story. So then I need to look at the total number of cards I need.
And I think the last page hasn't scanned, so we'll talk you through it.
So what we need to do is we need to just add them up. So I had on the top story 1 lot of 2 plus 0. And then on the next story I had 2 lots of 2 plus 1. And then I had 3 lots of 2 plus 2. And then if I go to the last one, I had n lots of 2 plus n minus 1. So then we need to actually work out, well, how can we add all these up? So then I looked at it and thought, what if I break it up into 2 additions? So I took the lots of 2, so 1 lot of 2 plus 2 lots of 2 plus 3 lots of 2 plus n lots of 2. I grouped those together because they're all just being added together, so that's okay. And then I added separately, then I grouped all the bits that I was adding on. So the 0 plus 1 plus 2 ... plus n minus 1. Okay, and then I took out, for the first part there, I took out 2 as a factor. So I had 2 lots of, and then inside I'm just going to have 1 plus 2 plus all the way to plus n. And then just the 0 plus 1 plus 2 all the way to n minus 1. Then I had to think of a way, well, how could I add up 1 plus 2 plus 3 plus 4 to whatever n was? And then I remembered about triangular numbers and about the rule that Gauss says that if I have, for example, the numbers from 1 to 100, he came up with the nice little way to do this and said, well, okay, let's add the first and the last. So when I add the first and the last, I get 101. Sorry. And then if I add the second and the second last, so 2 plus 99, I would also get 101. And then this pattern continues. So every time I add the first and the last, the second and the second last, etc., I always get 101. So I know 101 has to have something to do with it. And then I thought, well, how many pairs? He said, well, how many pairs would you have that would add to 101? So then, well, there are 100 numbers, but I'm pairing them up. So that means I have 50 actual pairs. And 50 comes from just 100 divided by 2. So then using that idea, I said, okay, I add the first and the last, so I have 1 plus n, or n plus 1. And then I'm going to have lots of pairs of those, and I'll have n divided by 2 pairs. Then I did the same thing for the 0 plus 1 plus 2 to n minus 1, and I add the first and the last, so I get 0 plus n minus 1 is just n minus 1. And again then, I'm going to have half of the number of that I have. Because I start at 0 and I go to n minus 1, I still have n numbers there. And so I divide the n by 2. And then I just played with the algebra. I can cancel out the 2's there. Because I'm multiplying each time, it's okay. So I've got n lots of n plus 1, which expands to n squared plus n. And then I expanded the second bracket to n squared over 2 minus n over 2. And collected things the same. So I had n squared plus n squared over 2, which is 1.5 n squareds, or 3 over 2. And then I had 1n minus n over 2, which is the same as 1n minus a half n. So you get n over 2. So that justifies or proves that my formula must be correct, because it shows that it will always work. Doesn't matter how many stories you have.
And that would have been an 8 in criteria B. Okay, so use this to help you and good luck.
Yep, good luck. Bye.